making measurements, the number of significant figures in your measurement represent the precision. It's not accuracy, but the precision of your particular instrument. So let's take, for example, in your common ruler. So just use the side upon which you see your ruler, and then using the centimeter scale, you should see most rulers have, well, the starting line is 0, and then you have 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have 1. So 1, 2, 3, 4, 5. So usually this is what you see in a ruler. So let's say, for example, in your first reading, so you get a reading that lies here, okay? And then let's say you have another reading which lies here, okay? So how would I record my measurement in this first and the second one? Well, for the first one, I can see that it is more than, if you can read, it's 0 to 1. So that means that it is subdivided into 10 equal parts. So that means that one line here, the smaller line, represent 0.1 of a centimeter. I forgot to write the centimeter. So usually, ruler, again, the metric side. The inches part is for the English system, but mostly we'll be using the metric system, so don't mind about that. So for the centimeter, so every line here constitute a measurement of 0.1 of a centimeter. So how would I record my reading if I get that this one here? Well, it's more than 1.1. So I would say that my ruler reads 0.1 of a centimeter. However, it's quite obvious in the first reading that somehow it is more than 1.1. Well, here's the thing. If you're doing measurement, you can actually approximate the last portion there. Since it is more than 1.1 but less than 1.2, I can actually say that this is around 1.13. And even, or centimeters, or you can even write as 1.12 centimeter. Both are correct measurements because when you're using a ruler, the ruler can only read up to 0.1 of a centimeter. For any measurement, you can actually approximate the last one. And this is what we call the doubtful figure. The doubtful figure or the doubtful digit. And with that, that means, that's the first reading, right? So that means that if someone reads your measurement, he will take that one as, oh, he's using a measuring instrument, well, most probably a ruler that can only read 0.1 of a centimeter, okay? Because I'm gonna take that one, the last one, as your doubtful figure. That means that it's beyond. Your instrument can no longer read that particular value, okay? So it must be for any measurement, you need to do that. So express. And for the second measurement here, are there any questions? Oops. Do we have to be exact, precise, or are we able to round? Well, just make sure, especially for a ruler, for example, because anyway, mostly we're using a ruler. So that means that if this is the case here, if you can read, if your instrument can read at a certain level of your, let's say in this case, you can read up to 0.1 of a centimeter, that means that is 1/10 of a centimeter. So therefore, in your final measurement, or when you try to record your measurement, you have to indicate the hundredths place. The hundredths place. You should place 0.3, or the second example will show you, let's say for example, in my view, it is exactly 1.4. So if it is 1.4, I will not just record 1.4. But if in your case, that is exactly 1.4, you place 0 centimeter. Because that gives an idea to the reader that, again, at least you are sure that it can read up to 0.4 of the centimeter part. This last part here could be just an approximated value, okay? So later on, I think we will be talking about errors also, Like you can write it down plus or minus 0.01. In this case, the at least for your range, it would be plus or minus 0.01 of a centimeter. Do you think that answers your question, Matthew? Is that what you mean? Exact, precise, or are we able to round? So actually, even though if you think that you think that that is 1.19, that is still a correct measurement. But if you say 1.2, but just make sure that if you think that it is exactly, it hits the 0.2 mark, so just put 0 at the end. Okay? So just put 0 at the end. So again, it's not wrong to whether, because again, that's part of your systematic error, like the way we try to measure things. Okay? So again, the significant digits of a figure, that's why it's not just if you're using a particular instrument, we can write 0.000. Okay? So the significant figures of your measurement tells you the precision of your instrument. Okay? So that means that even for your stopwatch, if your stopwatch can only read 0.01 second, so that means that, well, at least the last digit there is somehow your doubtful figure, especially if you are using a digital clock, for example. Okay. So if you're using a thermometer, for example, if you can only read, let's say, 1 degree of Celsius, so that means that in your recording, when you try to record your work, especially if it's like a analog one or thermometer that is an analog, so you place 37.1, because if you see that somehow the level of mercury is maybe more than 37 but very close to 37, so that would be 37.1. And actually I will not correct you if you also place 37.2. That is still acceptable, because anyway it's very close to 37. But if it's close to 38, I think it's also good for you to approximate the last digit as closer to 38. So you will place 37.8 or 37.9. Okay. So at least the reader that knows this stuff will actually say that, oh, okay, it can read your instrument. Your measurement can only read up to 1 of a degree Celsius, for example. Okay. So, but the next thing here is, how do we identify a significant figure? Because usually, when given a problem, usually these quantities will be given to you. Let's say, for example, for some problems, if you have noticed in most books, they will just not place 20 centimeters. Usually they will say 20.0. Sometimes you place 20.00 centimeters. And in that particular case, actually that is to emphasize the number of significant figures in your measurement. Okay? So if you're wondering why the trouble of placing the zeros at the end? Well, 20.00 tells you it has a different significant number of significant figure with 20.000. It has a different significant number of significant figures of just 20. Okay? So in most books, or as we move along, if you have noticed, and in some cases, we actually write our quantity in scientific notation. And again, we do that one in physics or in any other sciences, especially for physical sciences. That's very specific. That is to indicate the correct number of significant figures. And again, why is it that we try to express the correct number of significant figures? And that is due to the fact that certain measurement or certain instruments can only read up to a certain value. Okay,